up we have Brandon Richards, lead software engineer at Azenix, and he'll be talking about event-driven architecture, the Azure Service Bus, and .NET. We'll all be subscribing to your topic for the next hour.
That's right. Thank you.
Away.
Lovely joke. So my name's Brandon. I'm, as I said, lead engineer at Azenix, and that means I get to meet lots of companies and build lots of applications. My favourite things are Linux, open source, and event-driven code. And today, I'm going to be talking about Azure Service Bus. This is a fairly short talk, so I've had to kind of de-scope a little bit just to get it to fit in the 30 minutes, but I'll be working up into a bigger talk. So today I'm going to introduce the core components, the core concepts and ideas that drive Azure Service Bus. We're going to look at how to use Service Bus from .NET, because we're all .NET developers. We're also going to look at how to use Service Bus from Function Apps, which is a very good way to use Service Bus. And finally, we're going to look at a bit of infrastructure as code, how to kind of orchestrate doing some of that work, orchestrate kind of setting up Service Bus. So to start with, I'm going to introduce the concept of Service Bus. The Service Bus really is all about queues. There are some advanced features on Service Bus, but they're all just doing more stuff with more queues, with more stuff going on. So with a queue, you've got two things here. You've got a sender and a receiver. And the sender will send messages into a queue. And that queue is first in, first out. So when you put something in, it'll go in a queue in sequence, and then the receivers will pull them out, usually one at a time, but in the order they came. Now, that doesn't guarantee they're going to be processed in that order, because something might happen while you're processing it. You might process message 1, and it takes 2 minutes to process, and message 3 and 4 take 2 seconds. Well, you're going to be putting out message 5 before message 1 is finished. So if you want to guarantee any kind of order, there's a concept of a session that can let you do that. But generally, you're much better off keeping your messages kind of separate, not dependent on each other, and just fire them into a queue and then picking them up again from the receiver. What can a message have? Well, a message is really binary data. You can feed in a byte, you can feed in a string. Most people in .NET space will be putting in JSON. So you've got a JSON object, you serialize it, throw it into a message, send it, and away to go. Other options include, if you're worried about size, protobuf's a good option. If you're worried about sort of schema checking, there's something called Apache Avro, which is used a lot in the Kafka space. But that can work. It's a byte stream, so you can serialize anything you like to it. Now, Apache Avro has the advantage of having schema definitions and the ability to have a schema registry. So you can actually publish, I'm changing the schema now, and I'll publish the new version of the schema. When the receiver picks up a message, it can go, oh, I haven't seen this message before. I'll go to the registry, look up the new schema, and then validate it. So that's a good approach if you're looking to evolve your schemas. But most people I've seen in the real world are just sticking JSON, and JSON's fine. So as I've said, each message goes to only one receiver. And when you finish receiving that message, you take it off the queue. So you can't come along and kind of inspect the history here. You can't be, once it's taken out, it's gone. But there's two read modes here. So the first mode is receive and delete. So that means as soon as you get the message, it's already gone from the queue. So not really reliable for anything where the content of that message is important. You want to make sure you've done some work with that message before you receive it. But useful for, say you've got a stream where it's monitoring temperature from a sensor and it's just popping messages in. It doesn't really matter if you miss what happened 3 seconds ago, as long as you get the next temperature reading. Then you might be fine just to keep reading from that stream and just getting the message you get. But if you don't want to drop messages, don't use receive and delete. The second mode is peak lock. So peak lock's a little bit more complicated. So what happens is the receiver contacts the message queue and places a lock on that message. So that message at that point can no longer be read by any other receiver. For the lifetime of that lock, you've then got that time to work with the message, do what you need to do with that message, and if you are happy with that you've done what needs to be done, you can then fire complete, it will release the lock and consume the message. Or if something goes wrong, you can fire abandon and roll back, and that puts it back on the queue. So that way of working lets you implement what's called the at least once pattern. So you can guarantee that that message has been picked up at least once. It's pretty good, like that at least once is the only time you'll replay a message twice is if you do all your work and then just as you go, oh, I've completed it, the actual complete step fails. You use connection to the queue and you fail to complete it and you'll pick it up again. So most of the time, you're not going to see messages come through twice, but it's not guaranteed. So to be guaranteed, you call it at least once. And what that means for your message processing is you should make whatever you do to process that message idempotent. So if it plays that message again and does the same thing, you don't want to see duplicate database records being created. You want to keep track of this is the thing from that message. If I play it again, it's not going to hurt. I'm going to just update the same state and then move onwards. So that's queues. There are one way, first in, first out, and what goes in, what goes out. Well, queues only get you so far because queues is only one receiver can receive that message. But what if I want to do some kind of publish subscribe thing? I want to send a message and not keep track of just one receiver. I have multiple receivers that want to react to that message and do different things. Well, that's where a topic comes in. So the way a topic works is a topic is like a queue, but you just send a message in, and then a topic has a number of subscriptions set up against it. And when the topic receives the message, it clones that message and drops it into a queue for every single subscription. So it's not really that smart. All it's doing is it creates multiple queues and puts the one message in those multiple queues. So what that means for kind of subscribing to pub/sub changes is you need to have the subscription set up first before the message comes in. You can't do what you can do with, say, Apache Kafka and say, oh, what happened last week? Or go digging through the message history. You have to have your topic and the required subscriptions set up before the message comes in, and then the various receivers can read it. And once again, it's only one receiver per queue or subscription queue. But you've got some other options here. Not only can you drop your message in, there's the concept of filters. So filters are a service bus entity that you can add to your topic subscription, and they can sit there and actually filter the messages based on various rules. Now, messages have a binary body, but they can also have header properties. So you can write an SQL filter that can dig into the binary property, or an SQL filter that runs an SQL syntax on the headers. Or there's something called a correlation filter that just does a comparison against one of the header properties and then says yes or no. You can add multiple filters against the subscription, but if any of those filters say yes, then that message gets pushed through to that subscription. And finally, though I've never used this, at the end of the filters, you can also insert actions. Once again, these have an SQL-style syntax, and they can actually modify that message as it goes in. Now, I've never done this. It seems a bit overkill. I want to keep my messaging simple, but it's an option there. It's a tool you can use. So we've got a queue, and we can read from that queue. But sometimes things don't work. How do we handle errors? Well, every single queue that you create in Service Bus, and because subscriptions are also a queue, every single subscription has a kind of shadow queue next to it called the dead letter queue. So the dead letter queue is designed to catch things you can't process. And a thing can be placed in the dead letter queue for a number of reasons. It can be placed in the dead letter queue because your receiver said, hey, dead letter this message. It can be placed in the dead letter queue for some kind of processing reasons. The header size is too big. The filter SQL exception, the filter SQL you tried to run, that failed and it dropped out. Or there's a few other things. Every message you put in to a queue has a TTL, time to live. If beyond the kind of in-queue time of that message, that TTL is hit, it'll get pulled off and dropped in the dead letter queue. The other reason is max delivery count exceeded. Every time you attempt to read a message from the queue, and if you abandon that message and it goes back, it upgrades the delivery count. If the delivery count you've tried 10 times, by default the delivery count is 10. If you've tried 10 times to read that message and failed, it will then go, oh, I'm going to give up and abandon it and put that in the dead letter queue. And then you can inspect the dead letter queue, take a look at it. You can re-queue messages from the dead letter queue, or you can eventually take those messages out and abandon them. One thing to know about the dead letter queue is it does add up towards your storage. So when you set up a Service Bus namespace, it has a total amount of space. you can apply, and when you create a queue or a topic, they have a total amount of space, and the dead letter queue does add towards that space. So if your dead letter queue keeps filling up with errors, eventually you'll stop being able to receive messages. There's a number of feature sets based on basic, standard, and premium tiers. Basic is pretty much just queues alone. So you don't get any of that topics and subscriptions. Standard for me has been pretty good. It's still fairly cheap, and certainly, you know, I'll show you in a minute, I've been playing around with Service Bus, and just in my own kind of free tier, the tier I get with MSDN subscription, I get $200 a month of compute. I've used $1.80 or something in the last month just playing with Service Bus. So I generally use standard. With premium, the biggest bump you get is dedicated resources and the ability for your messages to be bigger. So the maximum message size in standard and basic is 256K. It goes right up to 100 megabytes per message for premium. But if you're sending around 100 megabytes in one message, I think it seems a bit big to me. You should probably redesign your application. All right, so let's go and take a look at some code. I've created a few resources, a few simple .NET applications, and I'm going to show you a walkthrough of how to push messages and how to receive messages. Now, the very first thing you need to realize when you start working with Service Bus and .NET is this problem. I've gone to Google and I have typed Azure Service Bus Message Receiver. Make it bigger. And I've got some hits. And all those hits are from a number of different namespaces. We've got microsoft.azure.servicebus.core, azure.messaging.servicebus, and microsoft.servicebus.messaging. So let's see a show of hands. Who thinks that this one is the latest one? Couple of you. Go on, don't be shy. Who thinks this one is the latest one? Or a few more. Yeah, ChatGPT knows. Who thinks this is the latest one? A few of you as well. Well, some of you are right, some of you are wrong. The latest one is this one. So that's what we're going to use. So you've got to just, you know, basically, you go to NuGet and look them up and see which one's most recent, see which one. Sometimes they're helpful to have this is deprecated, there's a new one. Sometimes they don't. You've just got to work that out. Once you've worked out what namespace I need, now I can start working. I've got a good, before I go, I've got a good ChatGPT story today. I was working with someone screen sharing. They had their Visual Studio open, their Copilot, and we were discussing a feature. We'd look at a few Stack Overflow posts and went, right, we're going to do it this way. So we started writing, okay, we're doing it this way, X, Y, Z, as per this Stack Overflow post. And then suddenly, this little URL popped up under suggestions. It's like, oh, it's just suggested a Stack Overflow URL. That's quite cool. So we go and copy that URL, paste it in. And it wasn't a real Stack Overflow URL. What ChatGPT had done was made up its own thing that looked exactly like a Stack Overflow URL, but it wasn't, it was just file not found. So watch out for that. It looked perfect. It started off with Stack Overflow, had the right shape, it had, you know, the user IDs in the right place. It looked like a Stack Overflow URL, but it wasn't. Yeah, it looks real, yeah. Yeah, I did ask the wrong question, yeah. All right, so I've started off, I've created this little CLI program, and I've called it Message Pump. Now, there's a new template, I don't know how new it is, but it's .NET New Worker. And that's quite a nice one, because it sets up some stuff for you, something to make a kind of background worker process. I didn't need to put the send in a worker process, but definitely the receive. Let's do it all in worker processes. So when you do a .NET worker process, you get this little bit of boilerplate set up for you, and it says your standard configure services and your program.cs, and you get this services to add hosted service worker, and that worker is itself a background service. So what that means is for the lifetime of your application, until you stop it, it will run this background service for you. And what we've got in this background service is, first of all, we've injected this thing called Service Bus Client. Now, Service Bus Client is your primary client for working with Service Bus, and this is an application singleton. You need to create one, and it's thread safe. It does all the work for you. Just create one, put it as a singleton in your system, wire it up to dependency injection, and I think that's what I've got going on here. Yep, so I've got services to add Azure clients, add Service Bus Client, and one thing we feed in is a Service Bus connection string, and I'll show you where to get that later. So then I created something. I'm going to send something. So I'm going to send this thing called a status message. So I've created a record called status message. It has an ID, a status enum. There's a bunch of statuses this application can engage. So I made up some stuff. I went happy and sad. Then I ran out of ideas, so I just picked a few other things that it could be. It could be enraged, a teapot, or not a teapot. So it's going to then randomly generate messages that say that. So now in my worker, I've got execute async. This is a worker shape. The cancellation token will be whenever I hit Control-C, it'll be looping until it receives stop, and then it will do the stop. So while I've not said stop, we are going to generate a random status and then create our status message record, which is our internal thing. And then we're going to turn that into a service bus message object. The service bus message then just takes a JSON string as its body. But I'm also going to show you some of the properties you can set. You can set a message ID as a header. You can set a subject string. That's a good one if you want to start applying filtering for certain things. I've definitely done some architectures where I've had a single topic, taking lots of different types of messages, and then having filtering rules against subscriptions that then route those messages based on type to different places. Well, you can do that by putting the type name in the subject and letting the filtering rules route those messages around. The other thing you've got here is a thing called application properties. That's just a kind of bag of string key to message, and you can put objects in there as well. And then finally, await send message async that will send one message. You've also got a version of this that will send a batch of messages. It will take a list and send them all in one hit. And then I wait 2 seconds and I send the message again. So let's go ahead and run that. I'm in message pump. I go .NET run. And you'll see it wakes up and starts pumping out every 2 seconds a message into the service bus. So the next thing I'm going to demonstrate is how we can take a look at those messages in the portal. I had more than that open. Session expired. Still expired. All right. Here I am. Yep, I've got, out of $210, I've got $209.85 remaining, so it's not expensive to run Service Bus. One thing to note about Service Bus, though, is there is no local kind of container you can run. You have to just run it on Azure. There is no, I know Cosmos has the local emulator, and you can do most things with that. There is no equivalent of that. If you really, really wanted to have some sort of local thing, you could try a different messaging pattern and kind of mock it out and do it that way, but it's so cheap for the testing purposes, you may as well just use the real thing. Although, you know, you're not doing unit testing there, you're doing integrations all the time. All right, so we've got a queue here, we've got a topic. If you want to create a queue, you can hit plus and you get some things here, give it a name, how big the queue size, the delivery count, which is how many times it attempts to deliver before it bounces out to its dead end of queue. You can set a time to live. 14 days is quite high. Well, it depends how long you want it to live for in the queue. But I would say if you want it to live for 14 days, put it in a database. Don't put it in a queue. Queues are supposed to be temporary. You can set how long the lock for. Remember when you do a peak lock, that's how long it will hold that lock for before the server goes, well, you've had that too long, I'm going to abandon it. You can ask to extend the lock time, but it will only wait that long. Although it says you can create a lock duration of days, but I don't think that makes sense to me. I think they've just copy and pasted that UI there. I don't know why you'd want a lock time of 5 days. Some other features. For a temporary queue, you can enable auto delete on idle. I guess if you're doing some testing and you're doing some testing stuff, you want to bring up a bunch of queues and then let them delete themselves, that's fine. Got a question?
Sorry, to butt in.
And yeah, that might be true. It,
So I'm completely confused
yeah,
by this UI.
yeah, this UI doesn't seem right to me. Just smells wrong in all the ways, doesn't it? Duplicate detection is a feature around, we've already talked about at least once. So duplicate detection is a feature that if you specifically set the message ID, it will set a time window and then reject any message with the same ID that comes through within that time window. It has to have a time window because it needs to keep that track of that state. So it will do that for you, and I leave it turned off because I just like to keep the thing fast. I think there's some cost involved in, computationally at least, in doing those checks. This is something you generally turn on. If it's been the message too long, don't just throw it away. Put it in the dead letter queue. Sessions lets you kind of group messages together. I've never used it, but it's useful for some use cases. And you can also say everything that goes into this message queue, forward it on. You've got a limit of 4 hops. So you can pretty much design any system you want with 4 hops. But if I think once you're designed and you need 5 hops, you've got quite a complicated architecture there. So you can have up to 4 hops of just bouncing messages between queues. But I find just a topic and subscriptions and filter rules do most of what you need anyway. The other thing I want to show you, for getting there, you've got this thing called shared access policies. And this can run at the namespace level, the queue level, the topic level, or the subscription level. And you can set up rules for whether or not you can manage, whether or not you can send to that queue, or whether or not you can listen to changes to that queue. And you get a connection string, and that's what you then feed into the Service Bus client to be able to connect to stuff. You can also do it with Active Directory. So you can set up Active Directory roles and do that all automatically. I find the connection string so easy that I've just been using those. But probably when we deploy my current kind of project to prod, we'll probably be switching it to Active Directory there. Next thing I want to show you is the Service Bus Explorer. So if I go through now, and go to Overview, then click on my queue, there it is, and click Service Bus Explorer. We can start exploring what's in that queue. So I can receive in peak mode or receive mode. Remember, receive mode will delete everything that's in there and just show it to me. So leave it in peak mode. I can peak from start. I can see all the messages I sent through. I can click them. I can inspect them. And I can choose to receive them and throw them away. So that is sending. It's now sitting there waiting for me to receive them. And if I wait too long, more than the TTL, for them to come out, they'll disappear and go into the dead letter queue. So let's move on now from that to receiving. That's not the one I wanted. So when we're receiving, and receiving is definitely, you do want to have a worker class for this because you're setting up a resource, and the resource you set up is called a processor. So you go Service Bus client, create processor, and that generates this thing called a message processor. And then this has a couple of nice bits of code. Who can remember these? Event handlers. Don't see them very often in .NET anymore, but here they are. Do you remember when you used to handle clicks in web pages with these? What a stupid idea that was. We all did it.
It was good. It was like Windows Forms.
Yeah, it was just like it was a Windows form, but it was on the web. It was amazing. All right, so we basically set up this handler called handle message async. So you say, yeah, when a message comes through, and this does the work for you, basically. It does the work of connecting up. It's polling the system. It's basically abstracts all the clever stuff it's doing to get you that message behind many layers. Just sets up this nice process that's going to just emit invoke handlers. We've got a handler for successful and handler for exceptions, and the handler looks a bit like this. We handle the message async, we process message event args, and away we go. So that's a pretty naive implementation, but the naive implementation does work quite well. If I create my other window, here's my receiver. If I .NET run that, there it goes, it's pulled back those messages and it's done. Now, what's good about the naive implementation is because we've used this processor, if any exceptions thrown here, we'll automatically catch that, it'll invoke this exception handler, and it will abandon the message for me. So by default, it does some quite sensible things. It'll abandon the message will go back onto the queue, and the message will then be picked up again straight away. So I can demonstrate that with this version of the reader where I've got an exception just being thrown in the middle of my handle message. So let's fire up the pump as well. So let me fire up the pump, pump some messages in, and let me switch to the version with an exception. And I'll do that here. And what you'll see is it's freaking out a lot. You see is if I stop the messages, you're seeing a whole lot more work going on than the number of messages that are going in. And the reason for that is that every single message that fails gets given, all right, you failed, I'll up your delivery count, put you on the queue. And it picks that message up immediately straight away and tries to replay it again and again and again and exhausts those 10 tries, bang up front, and it's gone. So I don't really know why it does this, because my only assumption is if you've just had something fail and you try it again immediately, it's surely just going to fail again. And if you do it 10 times, it's going to fail 10 times straight away. The only reason I think this is useful is if you're running a portal program, you're running Azure, and you've got that hooked up to a function instance, and every time you run a function, that's a little bit of money, then you can see why having lots of things run quickly and they keep failing, it's probably quite a good benefit to Microsoft there. But it's not probably the behavior we want. So we'll have a look at fixing that. The other thing I want to show you is something else you can do, and this is probably even worse, something you can do accidentally. I won't run it because I can see we're running short of time, is I've turned off this autocomplete messages thing here. And what I've also done is I made sure I have an exception. Where are we? Yep, I'm throwing an exception and I'm catching that exception. So I'm not finishing the work I'm supposed to do. But most importantly, I'm not completing the message. Now when I run this, what you see happening is it tries to run the message, fails to process the message, fails to release the message. So the message sits there and waits for its timeout. Then the lock timeout happens, it comes back on the queue, and 30 seconds later, it tries the message again. So try and avoid this. Basically, I've gone out of my way to break this. I've gone out of my way by saying, turn off autocomplete, and then I'm not throwing an exception, and I'm not completing. If I didn't turn that on, it would complete this function and autocomplete for me. But there's something you can watch out for. The thing I really want to show you, though, is how to do a more sensible back-off retry. I don't want to have a message fail and then it to reply straight away, because it's not going to help. Now, there might be some transient error. Maybe there's a 5-minute drop in connectivity. Mostly it's connectivity, or some kind of, something's been rebooted and it's going to take 2 minutes to come back up. I want it to try again in a couple of minutes and it'll probably work. So I've got this piece of code, and it's based on a Google sort of a GitHub post by this guy, Jeff Holland, who was working in the Azure space a lot of the time. And what we do, unfortunately, there's no magic setting you can send to Azure Service Bus saying, all right, let's abandon this message and reschedule it. So what you have to do is take over a little bit more. So what you can do instead is, when you get an exception, first off, we take the original message and we clone it. So Service Bus message has a constructor that takes another message, and it'll make a copy of that original message. Then what we do is we inject some extra settings into that message so we can keep count of how many times we've retried it. If we've got no more retries available, we can dead letter it. If we have some retries available, what you can do with a message is schedule it. You can say, run this message at this future point in time. So you can set that up, and the time to live kicks in after that schedule time occurs as well. So you say, all right, take this cloned message, schedule it to run, and we can say, all right, what's the retry count? Let's multiply that by 5, and let's then retry it. So if I take this version now, and let's turn on my message pump. And this is set to, I think it's set to sort of bounce a random number of attempts. I'll kill this and restart again. What you should see flowing through is scheduled to retry and wait 5 seconds. After 5 seconds, it will see it's scheduled, yes, retry 2 is waiting 10 seconds. All the time those are flowing in. And so now we've got much more sensible. It's not just smashing it, trying to get it through. It's taking some time. And every time it tries to retry, it's bumping up the time a little bit, just to give you a chance to get there before it gets to the edge. So that's what I like to do with messaging, to make sure I get a bit more sensible behavior from that retry behavior. So that's what I want to show you with raw.NET. So the key things to take away are use a worker service for your reader, because you can then set up a service bus processor and wire up the event handlers, and a little bit of code around taking over that retry capability, giving it a bit more, putting you in control of when we retry. So next thing I'm going to talk to you about is then hooking this up to Service Bus. Now, Service Bus is a real useful thing to work up with, to integrate with, Azure Functions are a real good service to use with Service Bus, because Azure Functions have a custom binding designed to accept Service Bus. In the same way that Azure Functions can receive HTTP requests, you set up the Azure Functions binding to point to a queue or a Service Bus topic subscription. It will monitor that subscription for you and wake up the function in order to run. So if you've got loads of messages in there, it'll wake up the function lots of times and actually dynamically scale out to deal with all those messages, and then scale back down. So it's elastic behavior based on the flow of messages going through your message queue. So let's take a look at what that looks like. I think I'm going to stop running now. So first of all, I have got a standard function app. So with a standard function app, you've got this code to wire up configuration. Looks the same, just in a slightly different shape, startup class now. And then you can create a message receiver. Let me unhide that. Okay, so this message receiver has a service bus trigger, and all you need to feed in is your queue name and your service bus connection string, and that's it. It will bind up to your systems. That string now will now be the message, that JSON string that came through. If you made this a type, it would try to deserialize that JSON into that object for you. You can get hold of properties such as delivery count, in queue time, directly against this method, and you can spit out all that stuff. The other thing that will happen here is it will do some smarts for you. It will actually, just like the autocomplete previously, if this function completes successfully, it will consume the message. If this function throws an exception, it will abandon the message. So that works quite well. We've got exactly the same problems we saw earlier, that it abandons that message immediately, requeue that message immediately, and just burn through your 10 delivery counts, and you ends up in the dead letter queue. So what I've got here now is a modification of the function app with backoff. So to do the same thing with backoff, we've got a service bus trigger, but instead we can bind directly to service bus received message. So we get access to all the properties. The other thing you can inject is service bus message actions. Now this is a tricky one. This is a tricky one because for this binding to work, you've got to call this property, for some reason, message actions. Give it any other name and it won't work. So watch out for that. Just call it what you like. This is set up against this trigger here, and it goes off. Whatever that type is, I'll sort myself out. So what you're seeing here is some of the weird behavior of Azure Functions. Just there's stuff done for you in those bindings, and sometimes you need to know the magic rules, and that's just one of the magic rules. But once you've got those, you can use the service bus receive message to pretty much do the same thing we did before. You can clone that message to make a new retry message, all the same logic's there, and you can use message actions to either complete the successful message, or you can use message actions to dead letter or to send. Remember what we're doing here actually, let me point that out, is what we're not doing is rolling back that message. What we're doing is cloning the message, sending the clone with a future retry time, and consuming the original message. So there is a tiny risk there that you end up with a duplicate because something fails between this step and this step. But that's pretty small. I've never actually seen it happen. So with this setup, you can do pretty much everything we've done, and then you get that elastic scale. You've got a system that will automatically scale up and add more instances, and if you've got loads of messages, it will create loads of function instances. If you've got few messages, it will scale it right down, and the cost is just how much do you want. You pour money in, and you get compute. So that is a standard function app. Now, a standard function app you can run in the big versions of .NET, the LTS versions. So you can't run this style of function app with .NET 5. You can't run this style of function app with the latest .NET 7. Now, back in the .NET 5 days when .NET 5 was released, it was kind of a big deal. I mean, they jumped up from 3 to 5, so it sounded like a big improvement, didn't it? And in fact, there was a lot of cool stuff. So when .NET 5 came out, I was working with some Service Bus functions. I'm like, wow, there's all this new stuff in Entity Framework Core that makes it better and more efficient, and it's going to give me better error messages. Let's move our function apps up to that. And then realized, no, we can't. We can't actually move our function apps. Well, why is that? AWS, they've got Lambda expressions. They run on .NET 5. Why can't we have Azure functions in .NET 5? And the reason is that they decided the way they built functions was it's an in-process thing. So if you remember the old .NET and IIS days, you could only run .NET inside IIS as an in-process thing. And when .NET Core came along, they introduced the idea of an out-of-process server. Well, that's the reason. They only decided to do an in-process implementation for .NET for the main LTS versions, meaning you were out of luck. You couldn't run .NET 5. So they went, all right, how about we come along and we make a new one. We'll make it an isolated process. And in fact, all the other ones you want to run a JavaScript, for example, on Node, that's out of process. There's bindings between the processes. But for .NET, they made it in process. So what they did is they made something called an isolated process mode, which is great. I quite like isolated process mode. It's looks it's like the jump from old .NET that had to be inside IIS to new .NET where it's a self-contained thing. For a start, it's a program. It's got a program.cs. You put configuration in program.cs instead of the weird stuff you were doing with this setup. Here, like this is kind of weird looking code, isn't it? You've got this assembly thing. You don't see that very often. And that's how you've got to tell the in-process thing to go and find just your setup. And it's all these weird extensions, where with the out-of-process mode, it's basically a console app that's got some libraries pulled in that turn it into a function app. Great, all very familiar. The problem is when they then came on to implement the bindings on top, they picked a whole new set of bindings. So you cannot use any of the binding code from in-process mode in out-of-process mode. And so it's a complete re-implementation of all the bindings. And when they re-implemented the bindings, they did not make them the same. Everything's different. What that means for HTTP is you can't cut and paste code. You've got to rewrite your HTTP. It's a different object you bind to. It's not called HTTP request message, it's HTTP request data. And it takes anyone switching between about 3 days to realize that's why nothing works. What you find for Service Bus is the Service Bus trigger in isolated process mode has just about enough features to make it work, but not enough features to make it work properly. So what you can do is you can bind up your Service Bus trigger to a string, and you'll get the JSON string. Or you can bind to an object, and it'll take your JSON and bind it to an object. What you can't get is that Service Bus message with all the properties on it. What you also can't get is that thing that lets you complete and abandon or retry dead letter the message. So you have no control other than I run without exceptions and it will consume the message, or throw an exception and it'll bounce it back. And I have no control over what I set that. It's just bounce back, immediate retry. That's the only thing I can do. Some other weird things. You can get hold of some of the properties that are on the message headers. The way you do that is you get this thing called the function context injected. And that's available to anywhere. And you can dig into that. You can go to function context, binding data, message ID. There's your message ID. Now, the other one you've got is this thing called application properties. So application properties is like a dictionary of key to object. You can put whatever you want in there. Now, when you get this back from the outer process binder, it's actually placed helpfully for you in your binding context, in binding data, in a thing called application properties. And what it is a blob of JSON. So all your properties have been turned to JSON is put there for you. So you can kind of get in there and get your stuff out. So what I did here was try to write some code where I attempted to do a retry. So what we do is very similar to what we used to have. If we have an exception, we accept the original message and try and queue a clone of the message with the future date. That works great. But the one thing we can't do at the end of it, if we get to the end of our retries, we have no way of dead lettering it. And I don't know, that's as far as I've got. I don't know how to dead letter it. One thing you could do is create a second queue with a time to live of 1 millisecond and just send all your messages there and it'll go in that dead letter queue. But then you've got to maintain 2 queues, and your second queue is just there just for your dead letters, and your first queue never gets any dead letters unless you never actually read from it in the first place and just times out from there. And so you've got multiple dead letters to go for. So overall, the experience has been, well, I've been working on this, this week and last week, and that's why I came here to rant, basically. Just today, we've abandoned all hope of running .NET 7 isolated function apps, and we're moving back to .NET 6 until .NET 8 comes along. Preview 1, all right, we'll move to that. We're bleeding edge. All right, let's get back to the slides, because it's nearly time for a beer. I'm thirsty. All right, so we've looked at .NET usage, we've looked at function apps usage. I'm just going to talk a little bit now about, we've looked at creating a thing by clicking and pointing. We've wired up some code to talk to it. We've talked to it through .NET code. We've talked to it through .NET functions code. Let's talk about ways you can work with Service Bus deployment. Well, first of all, there's the Azure portal. You can point and click and get stuff done. You have to use the portal for kind of exploratory testing because there's no local dev options. But you do get that nice Service Bus Explorer. So Service Bus Explorer, you can see messages, you can receive them, you can edit them. You can go to the dead letter queue and replay. So you select a bunch of messages in the queue, say, I'll put these back on the queue now, and it will replay that way. So, and I've seen that grow from being fairly clunky a few years ago to being quite a full-featured application there. So the other option is the Azure CLI. The resources we're looking at now, actually, were set up through the Azure CLI. You can put a few commands, create me a thing, create me a namespace, create me a topic under the namespace, create a subscription that's under that topic. You can do all that through Azure CLI. There is, of course, ARM templates, but the number of people I see writing ARM templates by hand is shrinking all the time because we've got things like Bicep. So Bicep is a domain-specific language kind of for writing templates with. It looks like a template, but it's got some stuff that helps you. Azenix is a HashiCorp Terraform partner, so I absolutely have to mention HashiCorp and Terraform, and it's a great tool. Where the later things in this list come through is they also have stuff that keeps track of state. So you've got your configuration, and it can read that. It also keeps track of what it deployed last time and can tell the difference. In some situations, you better go, well, you've changed it and you've added 3 things. I need to deploy 3 things rather than keeping track of what else is there. But finally, I'm going to go to my favorite one, and it's called Pulumi. And there's one very common reason, or a core reason, why I like Pulumi, and that's because the code you put into Pulumi to configure your infrastructure is .NET code. So if you want to create a resource group at the top here, and then create a service bus name inside that resource group, you've got this reference here to resource group name. What you assign it to is this object here. You're not getting it wrong. Inside an ARM template, you've got names, and you can put the ARM template. Basically, an ARM template for me is just a massive blob of magic string. This is code. It compiles. It's checked at compile time. So I can actually, set up these complicated streams of stuff and have everything compile time checked to be right. Now, Pulumi isn't perfect. It's a system that has lots of languages, and so in some of those languages, what the code you're writing isn't necessarily the most idiomatic way of writing that code, but it is at least C# code with C# objects that represent the things you're trying to build. I think where it might struggle is if there's new features, they might lag a little bit behind. They've got to then put in the shapes and the object shapes for the new features you want. Something like a namespace has been around for a while, it's really good. But there's one even bigger reason where I like Pulumi. And it's not just that I can set up the code using code, it's what I can do with that code. So I had quite a big application. There was like about 10 to 20 different microservices, all using Service Bus queues, all with those Service Bus triggers kicking around, so it was all function apps. So what I did is you can write some inspection code. So what I've got here is a few functions. One of them scans an assembly and finds all the attributes that labels the Azure functions. Then once you've found that, you look for the triggers that are Service Bus triggers. And when you've found that, you dig out the Service Bus attributes. And what you can do once you've found those things in your code is you can start building an object. So here's an object called Service Bus Details, and it has a list of all the queues, all the topics, and all the subscriptions it's found in my code. And then from there, I can feed it into Pulumi and say, right, for each, go and create me those resources. So now I've got the resources I need configured just in code, just in those parameters, and Pulumi will look at my code, inspect it, go, oh, you need these things, and then develop it for me. I think of it more like the way Entity Framework Core will manage a database for me. It's code first. The code specifies what I need. The infrastructure goes, you need those things, I'll go and make them for you. Just the same way a migration in Entity Framework Core will run off your code and go, oh, you need 3 tables, and away it goes. And that is why Pulumi is my favorite. Well, I think that's all the things I wanted to talk about today. So thank you for sticking around to the end and listening. All the code I've shown you today is in this simple GitHub. So go and take a look at that and give me a shout if there are any questions. Also, I work for a place called Azenix, and we are hiring. So if you're interested in working with the sort of things we're doing, then give us a shout. And apart from that, thank you for your time. Any questions? Yes?
What's the default behavior when your trigger tries to deserialize a string into an object and it just fails? Does it put it back onto the queue, or does it dead letter it?
That's a good question. So what's a default behavior when you try and pull an object off the queue and you try and deserialize it and it doesn't line up and fails? Yeah, that will throw an exception, and that will then go back on the queue, and it will just retry it 10 times. So, and so if there's one thing to point out is what I try and do is try and identify errors that can be replayed versus errors that can't. So transient errors versus non-transient errors. If you send me a message and that message can't be processed at all because it's wrong, there's no point retrying it because it's going to be wrong in 10 seconds time, it's going to be wrong in 5 minutes time, it's going to be wrong in an hour's time. Just get that straight to the dead letter queue. And then if I have errors that are thrown because I tried to write the database and the database wasn't there or responding, that's a transient error, put that back on the queue. So I have been known to actually take my application and go, right, I'm going to put 2 exception types. Here's the retriable exception type, here's the not retriable exception type, actually behave differently based on which exception was thrown, and therefore don't do work you don't need to do. You know it's wrong, there's no point retrying it, get rid of it. Good question. Yes? It's a good question. Is there a difference between setting up a Service Bus queue versus setting up a topic plus 1 subscription? They're pretty similar as far as I can tell. My recommendation would be to set up the topic plus subscription, because you don't know if you might at some point want to add a second thing to listen to the event happening. Certainly if you're doing kind of event-based programming where what you're meeting are events, if you want the opportunity for a second thing to start listening to the event, you're going to have to change it a bit if it's a queue, but if it's a topic, and even if it's got 1 subscription, you can start adding more subscriptions to add more listeners. And the other difference is topics aren't available until you get the standard. So on the cheapest mode, you only get the queues. Yes?
Both questions.
Yep.
poly addicted or poly
Yeah,
user.
yeah.
Is there any way you kind of convince it we'll just put a demo, or you don't like the poly?
It's a very good question. Yeah, the question really was, why didn't I use poly for this retry logic? And you're right, poly is a very good way to do it. But I would probably use poly if I was running a server and that server was making the connection, then poly is a good option. But if I'm using function apps have a limited lifetime. So you can't have a function apps, it times out after a minute or so. You can't have a function app that's sitting there waiting for the retry. You've got to put it back on the queue and let another function run to pick it up. So that's mainly why it's the function app capabilities. So and having the things scale up to add more function instances to deal with more messages. That's the reason I'm not using poly in this case, because of the scalability of function apps.
Yeah, alright. And the second one is with the Balloon actually. It's not come across. It doesn't do similar thing as Terraform plan, but it will deploy how it's actually delivering.
As the question was about Pullumin, is it similar to Terraform? Yeah, it's very similar to Terraform. I think in some cases it's actually using Terraform bits to do the job. It's just a layer in front of it. I think that's the case, but don't quote me on that, and I'll get in trouble if I get that wrong, because we're supposed to be, well, we are. We are Terraform partners. Come talk to us. Question for Jason.
So it sounds like the way that you've got Pulumi working is just you code, and you just do whatever you want, and then Pulumi dynamically configures Azure for you and creates resources and configures them.
That's right, yeah, that's it. It puts me in charge of everything. I love it.
So you've got code generating infrastructure as code generating.
Yeah. Well, I call it infrastructure as actual code rather than infrastructure as templating languages or JSON or whatever YAML bullshit they're trying to make you use. Sorry for the YAML aficionados. Yes.
How reliable is the queue sending of the queue? Like with Microsoft outages happening?
Well, that's a very good question. How reliable is? Well, I found it to be very reliable, certainly the sending of the queue. But obviously you should plan for failure. So, but yeah, I've not had huge problems. But yeah, if you have a big outage, those big ones that happen once every 18 months and takes everything down for a day. I mean, if you're cloud native on Azure, you're shit out of luck that day. That's the way it works. Yeah. Adam might have a different opinion there.
You can, so Service Bus Premium supports DR failover. So
Yeah.
You can actually get 4 or 5 line architectures. And that's why one of the main benefits of going to Premium is being able to architect the multi-region failover.
There you go. The Microsoft guy said you should buy more Microsoft.
There's a really big gotcha in that the DR replication replicates metadata, not your messages. So if you have Sydney and Melbourne workers, they can communicate with each other, but not across region. So it's something to be aware of, that the Sydney talks to Sydney and the Melbourne talks to Melbourne. When you create a queue, it creates it everywhere. But when talking in Sydney, it'll talk to only Sydney. It's a little gotcha that's kind of buried 7 bullet points down on slide 76.
That slide 76 has got all the problems. Well, I think that's it. Oh, one more question. Make this the last one.
When using topic and subscriptions, if
Yep.
the subscription fails and it puts it back onto does it put it back onto the topic and it sends it
Good
back
question,
to
yeah.
the subscription?
So when reading from a subscription fails, it puts it back on the subscriptions queue. So it's unique to the subscription. It doesn't drop it back on the topic. In fact, that's something to keep an eye on, actually. When I'm doing my retry I'm showing you, when I'm dropping it back on the queue, I need to make sure it goes onto the subscription, not back onto the original topic. So that's something I'll have to make sure I get right. Yeah. Otherwise, I'll be sending everything out to multiple times. Yeah. So, the test I've got here on a queue, that's a very good point. There's a potential bug there. If I keep sending things back to replay onto the topic, that's going to be a problem. All right. Well, thank you.